Welcome. In this video, we're going to use the intermediate value theorem to show that this polynomial here, 3x to the fourth minus 7x squared plus x plus 2, has a root between 1 and 2. Now, there's no need to graph this or figure out where exactly that root is. We just want to show that there is one. So first of all, let's say f of x equals 3x to the fourth minus 7x squared plus x plus 2. Since f is a polynomial, f is continuous on its domain of negative infinity to infinity, which is just equal to the real numbers. All right, so we have continuous. So since f is continuous on all real numbers, it is certainly continuous on the interval between 1 and 2 inclusive. All right, so we've laid the groundwork for the intermediate value theorem. Now let's evaluate our function f at x equals 1 and x equals 2. We're looking for a couple things. First thing we're looking for is that f evaluated at 1 does not equal f evaluated at 2. So let's check that first. F evaluated at 1 is equal to 3 minus 7 plus 1 plus 2 is equal to negative 1. F evaluated at 2 is equal to 3 times 16 minus 7 times 4 plus 2, which is equal to 24. Okay, so we've definitely verified that f evaluated at 1 does not equal f evaluated at 2. And we have everything we need to determine that there is, actually not even determine, to prove, to show that there is a root between x equals 1 and 2 here, using the intermediate value theorem. I'm going to make a rough sketch before I do that. All right, so we know f of 1 is equal to negative 1, so that would be about here. We also know that f evaluated at 2, so f of 2 is equal to 24. So that's way up here. Now, f is continuous, which means I should be able to connect these dots without lifting my pencil. Now, since I was able to connect these dots without lifting my pencil, and I will add, this is not an accurate sketch of f of x, but since I was able to connect these two dots, this orange dot and this blue dot, I was able to connect them without lifting my pencil. I had to cross the x-axis. There's no possible way for me to have gone from this point to this point without going past the x-axis somewhere. Since I had to cross the x-axis, this tells me that some point, and again, it has to be between 1 and 2, that some point where this function was equal to 0. And I say it has to be between 1 and 2 because if not, we'd have to loop back around, which would mean this would not be a function since we'd have at least one place where the vertical line test fails. That is, we had two outputs, two y values for the same input. So by the intermediate value theorem, there has to be some root, that is some place where f of x equals 0 between 1 and 2. And I'm abbreviating intermediate value theorem as IVT. And we're done here. We have shown that this polynomial has a root between 1 and 2 using the intermediate value theorem. To recap, we have to ensure our function is continuous on this closed interval. And we did that by recalling that polynomials are continuous on the domain of all real numbers, which means they're certainly continuous on this closed interval from 1 to 2. We then ensured that f evaluated at 1 did not equal f evaluated at 2, and furthermore, since f evaluated at negative 1 is below the x-axis, and f evaluated at 2 is above the x-axis, there's no possible way for me to sketch, that is, connect these two dots without crossing the x-axis. That tells me there has to exist some x value, some x equals c. I don't know where that is, but somewhere between here where I cross the x-axis, which means f evaluated at c has to equal 0. I hope this video was helpful.